Still looking at logarithms. Today we're going to be looking at expanding and condensing. Expanding, questions 19, 20, 21, and 22. So we're looking at expanding. So expanding, as it means, is you're going to make it bigger. Now, one thing we're going to do, multiplication. So let me write that thing down. Multiplication is going to expand to addition. We're going to, once we open it up, multiplication changes to addition. Division is going to change to minus. Now, let's take a look. So first of all, make sure you don't have any exponents outside of your parentheses. If you do, multiply the 5, in this case, the exponent on the outside, multiply to the exponents on the inside. Everything inside has an exponent. Technically here we have 8 to the 1. So if I multiply the 5 to the exponents on the inside, I have log base 2 of 8 to the 5 plus, remember times is going to change to plus, log base 2 of 7 to the 20. The 20, remember I multiply my exponents. Okay, and so the multiplication inside a log becomes the addition of two logs. Now, one thing we're going to do with the exponents, the way I'm going to solve the exponents, because I don't want to have them there, I'm just going to bring them to the front. Let me open myself some room here. My exponent, let me bring it to the front. So let me rewrite this as 5 log base 2 of 8 plus 20 log base 2 of 7. Now, if you can simplify one of your logs, by all means do so. I can simplify one of them here. Let me highlight this one. I can simplify, because in my mind, what I'm thinking of that one, let's take a look in red. I'm rewriting that as 2 to the x is equal to 8. I'm thinking of 2 to the x is equal to 2 to the third. So log base 2 of 8 looks like a 3 to me. So this looks like 5 times 3 plus 20. Now log base 2 to this, log base 2 of 7, we cannot simplify. Think about it. 2 to the x is equal to 7. Can you write 7 as 2 to the something? No, not quite. So I'm just going to write this as log base 2 of 7. So now to finish this, I'm going to call this 15 plus 20 log base 2 of 7. So I expanded it. I made it into a plus, and then simplify any logs if you can. Let's take a look at number 20. Let me open up some room here. Looking at the exponent, there's no exponent on the outside, so we're good. There's no exponent outside of the parentheses. So let me break this as log base 9 of u plus log base 9 of v plus log base 9 of w to the fourth. So multiplication inside a log, they split as addition of the same log. And then if you have any exponents, in my case I do, bring it to the front. So let me write this to the front of this log only though. So let me write this as log base 9 of u, nothing I can do in that one, plus log base 9 of v plus 4 log base 9 of w. So see how I brought the 4 to the front? That's it. Let's take a look at number 21. So to begin with, let me rewrite this as log base 7 of x squared over y to the 8th. Notice how the 2 outside of my parentheses, I multiplied it to each exponent on the inside. So let me rewrite this as log base 7th of x squared minus log base 7 of y to the 8th. Now I split it as a minus because it was division. And then any exponent, bring them to the front. So let me rewrite this. Let me do red so we don't get confused. 2 log base 7 of x minus 8 log base 7 of y. That's it. Let me get rid of the exponent on the outside. So let me multiply the 3 to my exponents on the inside. So we have log base 3 of x to the 3rd, y to the 6th. Right, the 3 on the outside, I multiplied it to the exponents on the inside. Technically, that was x to the 1. So that's why I got x to the 3rd, y to the 6th. Okay. I know when two letters are put together, we learned that back in Algebra 1, that is times. And the way I split a times, I'm going to split it as addition of two logs. So I'm going to go log base 3 of x to the 3rd plus log base 3 of y to the 6th. The next step, let me just do this real quick. I'm going to go 3 log base 3 of x plus 6 log base 3 of y. Now, one thing we're going to run into are radicals. Let me do an example here. Because you guys will run into this in your homework. Now, let's say I have log base 3 of the square root of x, and then I just have the y. The square root is only with x. So you guys can run into those. So to begin with, I'm going to say log base 3 of x to the 1/2 times y. Notice how my radical, I wrote it as a fraction. Remember, it was powered over root. We saw this a few weeks ago. Okay, so now I can call this log base 3 of x to the 1/2 plus log base 3 of y. The 1/2, I'm going to bring it to the front of the fraction. So I'm going to call this 1/2 log base 3 of x plus log base 3 of y. Now, 1/2, mathematically speaking, this is correct. But then we like to write this also as log base 3 of x over 2 plus log base 3 of y. The 1/2, we tend to write it as literally as a fraction. I put the 2 at the bottom. So you guys will run into some of this in your homework. So we learn how to expand, right? We started with 1 log, and I expanded. I finished with, in this case, addition of logs. Now we're going to learn how to condense. Now condense means basically make it smaller. Notice how 23, I'm starting with the subtraction of logs, right? 2 log base 8 of 5 minus 8 log base 8 of 3. I'm going to finish with just 1 log. What I'm going to do first If I have any fractions, so what I mean with fraction, let's say I have something like log base 8 of 5 over 2. Okay, let's say I had something like that. If I have any fractions, make it just one fraction in front of the log. So that can be simplified to 1/2 log base 8 of 5. Okay, so first of all, if you have a fraction, if your term is all a fraction, just convert it into a fraction on the front. Not our case here. We don't have fractions, but I'm just saying if you have fractions, make it a simple fraction on the front. The next thing we're going to do is the numbered in front of the log, bring it as an exponent. So question number 23, I'm going to write this as log base 8 of 5 squared minus log base 8 of 3 to the 8th. Okay, so notice how I brought the numbered as an exponent. I brought it up. And this is, I'm going to split it into, I'm going to condense it into log base 8 of 5 to the 2nd over 3 to the 8th. See how I just did it into one log? But because it was minus, remember minus in division. So that's it. If you have any exponent as a fraction, for example, let's say we had log base 8 of 5 to the 1/2 over 3 to the 8th. Like I said, you guys will have some in your homework, some that are fractions. If you have fractions as an exponent, convert it to radical. So log base 8 of the square root of 5 over 3 to the 8th. And so you guys will run into some of those, right? The exponent will be a fraction, the fraction converted to radical. Remember, the fraction is powered over root. Okay, let's come back here to number 24. To begin with, I'm gonna do the number in front of the log. I'm gonna bring it out as an exponent. So I'm gonna do log base 2 of a to the 5th plus log base 2 of b to the 4th. Have the same log, right? Log base 2, because it's a plus, I'm gonna condense this into log base 2, right? That's the same log I'm gonna have. Then I'm just gonna write a to the 5th times b to the 4th. Because it was plus, I condense it as times. Now, some of you guys might tell me, is that it? I wanna see if you guys are understanding. So if I write log base 2 of b to the 4th times a to the 5th, it's gonna confuse some of you guys on your choices. I'm gonna write it like that. Multiplication, the ordering multiplication doesn't matter. So a to the 5th times b to the 4th is the same thing as b to the 4th times a to the 5th. So some of you guys, just to see if you guys are paying attention, I'm gonna switch the order. Okay. Let's take a look at this one. I'm gonna write this as log base 4 of x to the 30 plus log base 4 of y to the 5th. And I'm gonna condense this as log base 4, right? I'm gonna just one log, because it was addition. When I condense it, I'm gonna condense it to times. So x to the 30th times y to the 5th. And again, to see if you guys are paying attention, I might write y to the 5th times x to the 30th. Here, number 26. Let me write this as log base 6 of x to the 5th plus log base 6 of y to the 2nd. And I'm going to condense this to just one log base 6, but then I pay attention. All right, there was a plus in between the log, so when I condense it, it condenses to times. So I could write x to the 5th times y to the 2nd, and to see if you're paying attention, I might write y to the 2nd times x to the 5th. Some of them do start with a minus in between. Remember 23, it was a minus, so that condenses to a division, a fraction. There you go.